The year was 2005. The date, December 14th, nestled amidst the St. Francois Mountains of Missouri, the Taum Sauk Reservoir held 1 billion gallons of water. It stood as a testament to human ingenuity, a marvel of engineering designed to generate power. But on that fateful day, the mountain pushed back. At 5:12 a.m., the unthinkable happened. The upper reservoir of the Taum Sauk pumped storage plant crumbled. A wall of water, taller than the Statue of Liberty, surged down the mountainside. The power of nature, once harnessed, had turned destructive. The story of the Taum Sauk Dam failure is a sobering reminder of the delicate balance between human ambition and the unforgiving laws of nature. It's a tale of engineering oversights, operational misjudgments, and the catastrophic consequences that can unfold when these factors converge. At the heart of the Taum Sauk plant was a marvel of engineering. A powerful pump designed to move massive volumes of water. This pump, the workhorse of the operation, played a crucial role in the plant's energy generation cycle. It pushed water uphill against gravity to the upper reservoir. However, this critical piece of equipment bore a fatal flaw. The pump's control system malfunctioned. Instead of shutting off at the reservoir's capacity, it continued to pump, relentlessly forcing water into an already full reservoir. The reservoir, designed to hold a specific volume of water, was pushed beyond its limits. The relentless inflow of water, unchecked by the malfunctioning pump, spelled disaster for the Taum Sauk Dam. The relentless pressure from the overfilled reservoir began to take its toll on the dam's embankment. The structure, designed to withstand immense pressure, started to show signs of strain. A small crack appeared, a hairline fracture in the mountain's armor. This seemingly insignificant crack, a testament to the immense pressure building within the reservoir, was a harbinger of the impending disaster. Water, the lifeblood of our planet, possesses incredible erosive power. With each passing moment, the crack widened, a silent testament to the relentless force of the overflowing water. The mountain, once thought invincible, was about to be humbled. The dam, weakened by the ever-expanding crack, finally succumbed to the immense pressure. The once solid structure crumbled, unleashing 1 billion gallons of water in a torrent of destruction. The wave, a roaring monster of white water, surged down the side of Prophet Mountain. The deluge, a force of nature unleashed by human error, ripped through the landscape. Trees were uprooted, boulders tossed aside like pebbles. The power of the water was absolute, reshaping the landscape in its wake. The once tranquil east fork of the Black River transformed into a raging torrent, carrying away everything in its path. The fury of the water, unleashed by a failure of engineering and oversight, was a spectacle of awesome and terrifying power. Section 5. The Absent Eye. The Taum Sauk Dam, unlike many of its counterparts, was remotely operated. This design decision, while seemingly practical, meant that there were no human eyes on the ground to detect the unfolding crisis. The control system, designed to monitor the dam's vital signs, failed to raise the alarm. This lack of on-site monitoring proved to be a crucial factor in the disaster. Had there been personnel stationed at the dam, they might have noticed the telltale signs of trouble, the malfunctioning pump, the rising water levels, the telltale crack in the embankment. But the control room was empty, the fate of the dam entrusted to automated systems. The absence of human vigilance, a cost-saving measure, allowed the crisis to escalate unchecked, with devastating consequences. Section 6. Pushing the limits. In the years leading up to the disaster, the Taum Sauk plant had been operating under increasing demands. The push for greater energy output, driven by economic factors, placed additional strain on the dam and its systems. The equipment, designed for a specific operational range, was being pushed to its limits. This relentless pursuit of efficiency, while understandable from a business perspective, came at a cost. The increased operational demands placed undue stress on the dam's infrastructure, increasing the likelihood of a catastrophic failure. The Taum Sauk disaster serves as a stark reminder that even the most robust engineering marvels have their limits. Pushing these limits in the pursuit of profit or efficiency can have dire and unforeseen consequences. Section 7. Picking up the pieces. The immediate aftermath of the Taum Sauk Dam failure was one of shock and devastation. The floodwaters, having subsided, left behind a trail of destruction. Homes were damaged, businesses destroyed, and the landscape forever scarred. Miraculously, there were no fatalities. The human cost, while significant, paled in comparison to the environmental impact. The floodwaters, laden with sediment and debris, surged into Johnson's shut-in state park, a pristine natural area. The park, a popular tourist destination, was severely damaged. The road to recovery was long and arduous. The state of Missouri, along with federal agencies, launched a massive cleanup and restoration effort. The economic and environmental costs of the disaster were substantial, a stark reminder of the price of failure. Section 8. Engineering under scrutiny. The Taum Sauk Dam failure sent shockwaves through the engineering community. How could a structure designed by some of the brightest minds in the field fail so catastrophically? The investigation that followed was thorough and unflinching in its pursuit of answers. The findings of the investigation were sobering. It became clear that a combination of factors, including design flaws, inadequate monitoring systems, and operational misjudgments, had contributed to the disaster. The engineering community was forced to confront uncomfortable truths about its own practices. The Taum Sauk disaster served as a wake-up call, a stark reminder that even the most sophisticated engineering projects are vulnerable to human error and unforeseen circumstances. It highlighted the need for rigorous design reviews, robust safety protocols, and a culture of vigilance within the engineering profession. Section 9. A legacy of change. The Taum Sauk Dam failure, while a tragedy, led to significant changes in the way dams are designed, built and operated. The disaster spurred a wave of new regulations and safety standards aimed at preventing similar tragedies from occurring in the future. The engineering profession, humbled by the Taum Sauk experience, embraced these changes. New technologies, such as advanced monitoring systems and early warning systems, were developed and implemented. The disaster served as a catalyst for innovation and a renewed focus on safety within the industry. The legacy of the Taum Sauk Dam failure is one of lessons learned and improvements made. The disaster, while devastating, ultimately led to a safer and more resilient dam infrastructure, not just in the United States, but around the world. Section 10. Echoes of Taum Sauk. The story of the Taum Sauk Dam failure serves as a cautionary tale, a reminder of the immense power of nature and the importance of respecting the delicate balance between human ambition and the environment. The echoes of that fateful day in December 2005 continue to resonate, urging us to learn from past mistakes. As we continue to develop and implement ambitious engineering projects, the lessons of Taum Sauk must guide our decisions. We must prioritize safety, embrace innovation, and never lose sight of the potential consequences of our actions. The future of engineering depends on our ability to learn from the past and build a more resilient and sustainable future. The rebuilt Taum Sauk Dam stands today as a testament to both the destructive power of nature and the resilience of human engineering. It serves as a constant reminder of the importance of vigilance, innovation, and our responsibility to harness the forces of nature responsibly.